Anyway, that's enough of all that. Thank you very much indeed. It's a real pleasure. And today's lecture, which is on water system and sewage system, strikes me as one absolutely central to our interests in Cambridge at the moment. We have enormous water and sewage problems in this region, as you will know, and in Cambridgeshire, and they've been occupying us a great deal over the summer, especially during that heavy, heavy drought that we were suffering, very much so. And we often forget, of course, that in Cambridge, we're technically classified as semi-desert. But it might not have felt like it, of course, in the recent weeks, but during summer, it certainly was. So it's a very important lecture. Now, Natalie is a perfect person to do this. She works for the National Water Industry Account Manager at QCL, very important. And she has a PhD in Civil Engineering and Microbiology from Sheffield University. She's also an MSc in Microbiology from Cranfield, I might emphasize, so very highly qualified. And I believe, Natalie, you've just been appointing visiting researcher at Sheffield University as well, to add string to your bow. She's a STEM advisor as well, an ambassador on the need for understanding and valuing water systems, which is certainly something that we should be doing. And she always looks at the question of how technology is going to be an extremely important asset in achieving all this. And the final thing I have to mention, because it makes her very exciting, I gather you're a trained scuba diver, is that right, Natalie? Yes, so there we are. So we'll be diving into the subject of water, and I hope not too much sewage today. But let me hand over immediately to Natalie, and thank you so much for coming to speak to us today.
Thanks so much. Hi everyone, I'm just going to share my presentation with you, one sec. So yes, my name is Natalie, and thank you very much for coming over today, either on Zoom or in person to listen to me present. I'm a bit of a rebel, so I might go against the rules a little bit and ask for some questions as we're going along rather than waiting until the end. But I'm going to use the excuse that it's because I work in innovation, so we've got to change things up. We can't keep doing the status quo. So why am I here? Why are you here listening to me speak today? So I started off, I lived in Herefordshire, that's where I grew up, so quite far from Cambridge, and I did my BSc in biology. So I'm actually a microbiologist by background, and all things tiny are, you know, that's my bag, that's my field of expertise, my field of interest, and that's why I did my master's in Cranfield. But I was actually sponsored by the water utility Anglian Water, who supply water and sewerage services to the east of the UK, to do my master's at Cranfield. You might not have heard of Cranfield University. They are postgraduate only universities, so they don't come up like in the league tables, and they specialise in all the things that a country needs to survive under dire circumstances. So they specialise in things like water, security. It's a very peculiar university in that it's not got a train station and it's not got a pub, but it has got an airport. So quite a strange setup for a university, very different from Cambridge as a campus. I was actually there presenting yesterday, actually. But yeah, I did my master's there on an organism called Cryptosporidium, which if you decide to go to your local river and you have a little swig of your local river water for some unknown reason, and you get sickness and diarrhea due to that, it's quite often Cryptosporidium that is the cause of that. Very well-known organism in the field of water because it's very resilient to chlorine, which I hope to speak to you a little bit about later. And then I carried on working at Anglian for a little bit before then starting my PhD, which I'm hoping to speak to you about today if we have time with the University of Sheffield. And I've carried on as a visiting researcher at Sheffield just to try and get those papers out the door. I think it's really difficult because all my master's work, my PhD work at the same time, I was working with Anglian Water. It can be really difficult to get approval from the industry partners that you're working with to publish your work, especially if it's very visible, very much of interest in the public eye. So yeah, still trying to get some papers out the door for that. And now I work for a company called QCL. It stands for Quadrachem Laboratories. There's a reason why I shorten it to QCL, because that's quite a long name and it's quite difficult to say. And I am their National Water Industry Account Manager. What does that mean? So I work with different innovative technologies to get them from sort of trial stage to actually implemented in the UK. And my aim for doing this presentation with you today is really to show you some of the really exciting, innovative work that we're doing in water, because I think most people, when they think of water, they just think of, I don't know, the rain, an umbrella, maybe the bad publicity that we've seen some of recently in the news. They don't necessarily think of excitement and research and drones and really exciting technology and exciting stuff that's actually happening. So my one aim for today, even if you don't learn anything new and it's really terrible and you never want to see me again, I hope at least that you gather that some cool stuff is happening in water, and we really do care, and we're trying to make water better. Even if I think in the past the water sector has been something secret, something hidden, something that you don't necessarily, as long as your tap is turned on and water's coming out, as long as your toilet is flushing and not, you know, overflowing into your house, then it's working fine. But actually there's some cool stuff going on that I hope to tell you a little bit about today. So along that theme, I've got sort of 3 parts to this presentation today. I'm definitely intending to do part 1 and part 2. Fingers crossed we'll have time for part 3. So part 1, I'd really like you to be able to speak like you're a microbiologist in the water and wastewater sector. Now, if you do have a background in microbiology or an avid interest in microbiology, I know we've got some pretty academic people on the call or in person with us today. Please feel free to turn off your video and go have a cup of tea, because you will know all of this. If you're in the room, you know, just plug your ears and maybe hum a tune. Because this is going to be really boring for you, but I just wanted to bring everyone sort of up to speed, because this is in particular something that is really of interest to me, and I just wanted everyone to know about it basically. So part 1, turn off your Zoom and go for a cup of tea, microbiologist, how to understand the microbiology of water and wastewater. I should say part 2 is going to be the stuff that you're here for, sort of combined sewer overflows, publicity in the news that we've had recently on that, what it actually is, what we're doing about it, and what some innovative techniques that we're doing at the moment to try and solve that, fix that, improve that situation. And then part 3, if we've got time for it, I didn't just want to focus on wastewater, I also wanted to give you, there was also water there in the title, so I also wanted to add in a little bit of drinking water as well. So if we've got time for that, that will be a little bit around some of what I did in my PhD and some of the interesting, innovative technologies that I worked on as part of that. But the overarching theme of all of these things is microbiology, so that's why I wanted to give you an introduction to that. So part 1, by the end of this, I want you to be able to understand this description. That is my aim. So normally we've got quite a few people on Zoom, so normally I'll try and get people to tell me what these things mean, but I'm not going to do that this time, just because there's too many people there. But I want you to try and understand this. So if you already understand this, this is your sign to get a cup of tea. So this is part 1. So the highlighted area is what we're going to focus on first. So the reason for that is all organisms have these 2 names, and I can see some nodding in the room. You might already know this, but I know that you do art lectures as well as science, so you might not have a background in this. So these 2 names are the genus and the species of an organism, so that's what we always use. And when you're using these, you should also do the correct capital letters, and the italics are really important as well. So if you want to try and fool a microbiologist, this is how you write the name of a microorganism. And this is what the genus and the species mean. It's just to really identify what it is you're talking about, say for instance, Homo sapien. Next step, gram negative. So this is the background for how to categorize microorganisms, but this is only bacteria, and so this is a type of staining that's quite common, and the differences in different dyes that you can use to detect different types of organisms. So that's what that gram negative just means on that description. It basically means because of the cell wall composition, it takes up or doesn't take up a certain type of dye, and then you can identify it underneath a microscope. So this is a really important one if you want to try and fool any microbiologist. And normally, if you have a question if you want to ask a question, a good one to ask is, is this research exclusive to bacteria, or is it for all microorganisms? That's a top tip for you, because quite often, especially people who don't work in the field of microbiology, they'll be speaking specifically about bacteria, and actually they can be referring to lots and lots of different organisms, or vice versa. So they can give a talk all on bacteria, and you could say, I was just wondering if you've done any research into fungi about this. And normally the answer is no, because it's not very well studied compared with bacteria, but that's just another top tip for you. There's a lot more than just bacteria out there. And then just about categorizing those microorganisms a little bit more. So as part of my PhD, I was doing some DNA analysis, but we kind of cheated. So in academia today, quite often what they do, or what we would do anyway, and what my colleagues do and other researchers that I'm working with, we quite often actually ship off water samples to places like Mr. DNA, which is a company based in the USA, and we just pay them, and they extract the DNA for us, and we just get sent a report back of what specific organisms there were in that water sample. So we are kind of cheats. We do pay for other companies now to do our analysis for us. And then finally, one thing that's really important specifically for water is the adaptation of microorganisms. So as an example, in wastewater treatment, which I'm not going to go into today because I wanted to focus instead on those sewer overflows. In wastewater treatment, it is primarily the microorganisms that are digesting the sewage that you want to transfer from sewage into water that's of good enough quality to be discharged into rivers. And currently what we use aerobic bacteria for that. So that means microorganisms that require oxygen to survive. But we're actually in the water sector at the moment trying to move away from that, and we're trying to instead start using some more anaerobic bacteria to do that work, because to pump in all the oxygen that those microorganisms in those big tanks, if you imagine the look but not the smell of big cylindrical tanks of sewage that you have to blow a lot of air into, and you've got to blow the air in all stages of this tank just to keep those microorganisms with a supply of oxygen at all times. Very energy intensive, very expensive, especially with the current prices. They also have like triaging periods, so that energy that they're using is more expensive during peak hours. So yeah, it can be really expensive, and we're trying to move away from that. We're also doing some work at the moment turning off the aerators at certain points of time. So if you know you've not got a lot of microorganisms in a tank, or you know that they're not working very hard, you can turn off the oxygen at a certain time to try and save some of that energy. But it's a traditional way of treating the sewage, but it's not the most effective or efficient really. And microorganisms require different food sources, environmental factors. So particularly in a wastewater environment, we're trying to produce a sewage which isn't going to produce gases that could, for instance, knock people out, unless that's something that we're intending to do. So you might see, if you're driving down the motorway on the train, sometimes you see these big cylindrical tanks with like a bubble on top of them. They're normally a dark green color. So yeah, big tank, round top on it. So this is normally some kind of digester. So that essentially means we're burning sewage to produce gases that we're then using for energy, as well as also producing like a char, so like a charcoal type material that can then be put on fields and so on. So we really need to understand the microorganisms that are in the different environments and in the sewage to make sure that we're feeding them the right food that they need for us to use them. We're basically just forcing these microorganisms to do our bidding, but we need to make sure we're giving them what they need to do the job effectively and to not hurt anybody in the process. And some of these gases can be really bad. There was a big explosion over at Wessex Water a few years ago that made the news. So when things go wrong, things really do go wrong. And I find that working with the water companies, they are very risk averse as an industry. There are some sites where you've got to, for instance, hand in your laptop and your phone. You're not allowed any technology on site at all, just because of the risk of explosion there, just from having sort of your phone on site, which is very difficult when you're trying to make almost like a broken instrument, which is a bit like a broken laptop, work. You've not got any, I think in this day and age as well, not having access to the internet, or to be able to take a photo of the error message that's on the screen. Going back to basics, doing everything by hand on paper can be quite a challenge for some people, especially if that's the industry that you've grown up with. So yes, microorganisms adapt to all sorts of environments, and more on this a little bit later. Everything is all in balance as well. So I like to give the sort of, you know, the food web analogy really. You've got different microorganisms that consume different microorganisms that consume different microorganisms, and everything is related and everything is in balance. So if you do one thing to try and support the growth of one organism, you might be killing off a different organism. There's only so many places that they can live. There's only so much food available. And it's the same as like a, you know, in the real world, a large animal, these microorganisms, everything is in competition to survive. So that's one tip for you when talking about this topic, is really like, just think of it, just talk about the whole issue as though they were real life wild animals trying to survive in the wild. Rod shaped, that's an easy one. It's shaped like a rod. E. coli is. So they come in lots of different sizes, lots of different shapes, and I'm going to talk to you in a little bit about some of those. Coliform. So coliform bacteria are a type of bacteria. They are of particular interest in the water sector because they are how we tell if tap water is safe to consume or not. So you might not know this, or you might know this, but water companies do random sampling. So they'll randomly choose a postcoded area, and they will go to properties. They will knock on the door during the day. They will show you their ID to you, and they'll ask if they can take some samples of your tap water. And so I don't know if anyone's ever had this. I personally have never had this. But yeah, they come and sample your water. I have quite a few problems with this as a method. The first of which being quite often the same type of property is sampled, with the same population dynamic is sampled. So they're only going to be sampling during working hours, 9 till 5. So it's never going to be someone who is working away from the home who's going to have their house sampled, because the water sampler will knock on the door, no one will come, and then they'll go next door. Another problem is the water sampler can choose the house that they sample at. So if you had 2 identical houses next to each other, you're a water sampler. If your water quality samples fail, you will have to go back to that postcoded area, and you'll have to take a repeat sample from that exact same property. So on the left, there's a house that looks pristine, most beautiful garden you've ever seen. On the right, you've got a really scruffy, maybe they've got some broken down cars within the garden. Maybe there's a bath with some weeds within it. Which of the two, you know, there's a lot of human opinion involved with that decision. So that's just another one of the problems. So they do a full tap clean before then taking these samples. So for instance, if in your property you've got a cat who licks your tap, just as an example, that shouldn't be a problem, and you shouldn't fail your water quality samples based off that, because they will do a full tap clean. In fact, you know, maybe hang outside your house and try and beckon in any water samplers that are passing if you want a very thorough tap clean, because they do not want those samples to fail. So why focus on coliforms? Well, they're easy to grow. So they take these samples, and there are some that are done right then and there. So things like turbidity, they'll have a handheld turbidity monitor. That's turbidity is to measure the clarity of the water, so how cloudy it is. Chlorine, they will do right then and there. I used to, when I worked for Anglian, I had a little chlorine testing kit that I would take to presentations, and I would do a chlorine testing live, because it's quite a nice pink colour change if chlorine is present. But unfortunately, they wanted their property back, which is a shame. So apologies for that today. So yeah, there's some that they take there, but the most important ones are the microbiology samples, which they then take to the lab. They go on agar plates, so it takes about 2 days, 2 to 3 days for anyone to get the analysis back. So if you're actually trying to monitor the water quality of that tap, you could argue, I think, that if you go back to that property and you sample again, that specific patch of water had already been used by the household. It could have been consumed by that person in that 2 to 3 day time period within which you're then taking a repeat sample. So quite often, if a sample fails because there's positive coliforms there, the resample that is then taken is going to be negative quite often because the risk has already sort of passed. Well, by the way, this presentation, I should have already said, this is all my own personal opinion. This is not the opinion of my company or of any water utility. This is my personal opinion, having worked on this for some time. So the problem with coliforms is they're slow. It is just a grab sample. You've got that human error. So one thing I was working on during my PhD is using different technologies. So one technology that's used quite a lot in the water sector at the moment is called a flow cytometer, which has been something that's been used for quite a long time in the field, the area of blood, to detect the different sizes and shapes of, to work out what your blood cell concentrations are. So we started using that in water really heavily the last few years. It's become apparent. And this particular instrument, it uses lasers to count individual numbers of cells. So rather than getting a value of 0 coliforms, 1 coliform, 2 coliform as an example, instead you always get a positive value, and you could have 100,000 cells. You could have lots and lots of cells. But on the negative side, because they're such high numbers, it's quite difficult, I think, especially with the public and public information of water companies sort of sharing that data. There's a big risk there. Tap water is something that people really have to trust for it to be a useful measurement at all. So if you're telling people that there's lots and lots of cells in their water, that can scare people, and then people might not drink their water. But microorganisms are everywhere. They're everywhere all around us. We're breathing them in. They're on our skin, living on our skin. They're within our bodies, digesting our food for us. So they are everywhere. But I do feel like in the public there can be some misconception regarding that, and I think that's something that we're going to have to work on if we do want to use these analytical techniques rather than just presence or absence using coliform bacteria. Then that's something we're going to have to work on and consider, I think. So I've come to pretty much the end of part 1 now. So hopefully you understand this paragraph, and it's also given me a bit of an opportunity just to speak with you about some of the big challenges that we have in the water sector, coming across both water and wastewater. Is a little bit of an introduction to the topic, really. So some final tips from me: if you are trying to pretend to be a microbiologist in water and wastewater, don't panic, especially when you hear those long Latin names of some of those different microorganisms. Think of the microorganisms like plants or animals. So they need food, a place to live, they're in competition, they're stubborn, they are everywhere around us. There's a lot more than just bacteria out there, and they're not actually all bad. They can be helpful. So we all like beer, we all like yogurt. These are all some helpful things that we get from microorganisms. So on to part 2, which is the real reason why you're here today. So if you did go for your cup of tea, feel free to come back now, because this is the bit that you're interested in. So rather than talking about wastewater treatment, it is more generally wastewater, to focus on those combined sewer overflows. So you've probably seen a lot of information in the news about this. It's been quite negative. I think these topics, combined with the news of sort of CEOs being on a lot of money in the water sector, I think those two have been the two sort of dominating topics now for some time in water. And I think it can be really difficult when you're working in the sector, because it's not really down to an individual or an individual member of staff. There's not one person in the company who's like, yes, let's make this happen. Today, what I want to do today is pollute some rivers, please. And I think the media can very much sometimes play things to be the negative. Like I've said, we're quite a quiet sector, and as long as everything is running smoothly, you don't really think about us, you don't really contact us. And today, with the increasing use of social media, actually, people are complaining a lot, and a lot of things that we sometimes are not our fault. So things like people flushing wet ones down the toilet, for instance, that's the water company who's going to have to deal with that and fix that. But actually, it's an individual who has caused that. I attended an interesting presentation recently about a water utility who is tracking down individual people who have been flushing wet ones down the toilet and threatening to send them to court if they continue tracking those wet ones through the sewer system, which is quite exciting. So what actually is a storm overflow? So how our pipe network has been designed in the UK previously is that it collects both of the sewage that you're generating within your house, as well as the rainfall and so on that's falling from the sky, so as well as that environmental water, it's also household water. And those two combined are within our wastewater pipe system. So why is this a problem? We have quite an old network in the UK, and even on the drinking water side of things, we have some pipes that are Victorian era. We have on the drinking water side of things an average pipe age of around 85 years. We have some very old pipes in the ground, and we have a massively increased population size today compared to when these pipes were first built. And there's an infrastructure challenge here as well, in that just digging up all the roads required to replace all of these pipes would cause mayhem for people. We actually have enough water and wastewater pipes in the ground in the UK to go from the earth to the moon and then back again. So we have a lot of pipes in the ground, and they're not as good as they were once. So what this means is we're actually permitted in regulations sort of put in place by the Environment Agency, that under extreme rainfall events, this combined sewer network can overflow into local environments. So there's an added challenge here regarding the regulations. Extreme weather events, as you might have seen in the news, are now almost the norm, really. We have a lot of extreme rainfall events now. We have a lot of extreme everything in terms of climate events. So the frequency of this occurrence has not only been due to the increased population producing increased sewage, a large part of that is because of these increased rainfall events. And also, I think in the past this was happening and people didn't necessarily know about it. So again, I think social media, public interest really has really set this off. And I think personally that this has all come from David Attenborough. I think the Blue Planet series about microplastics in water really kicked something off for us as a sector. People suddenly really cared about plastics in water and microplastics in water, which we're implementing all sorts of interesting, large-scale technologies on the drinking water side of things to try and investigate this. We're only just really developing the technologies to be able to detect some of these microplastics. But that's, I think, set us off on a big spiral, really. And now, obviously, this is the next challenge. At a conference I was at yesterday, I actually asked the question, should we be, as a sector, allowing the public to be dictating what our next big challenge is as the water sector? Or should we be paving our own way? Should we be telling the public what the challenges are and sort of, pinching them to the post almost? Or should it be the way it is at the moment, and the public are informing us what our next biggest challenge? Because combined sewer overflows, this problem has been going on for a very, very long time. And it's only now really that we're getting as an industry the funding that we need to be able to try and tackle this, because it has been ongoing and ongoing. So should it be driven by the public? Should it be driven by regulation, the government? I don't know the answer to that. That's far beyond my pay scale, but I can have lots and lots of questions about it. So this one, just as an example, I just pulled this off the internet. So, and these are some of the concerns about it, really. So first of all, in that headline, raw sewage, it's always diluted. 100% of it is diluted, because it's only when the rainfall event's happening, and the problem, the vast majority of that water is coming from rainfall. Yes, it's not coming from the sewer network. So I found raw sewage a lot in headlines, and it's not raw sewage. Quite often it can be screened as well. So you can have screening systems within the sewer to then remove solids. By solids, I mean poo. Just so we're aware, we use like suspended solids quite a lot, meaning poo, but that's what it means. And it can also, so I was at a brewery 2 months ago, this local brewery down near Gatwick Airport, and they were looking into implementing their own wastewater treatment on site for the first time. Just a small local craft brewer it was. It was costing them £50,000 to tank away all of their sludge, which is sewage. So they were implementing sort of settlement tanks and so on. So it's just another one of those big round cylindrical tanks to settle the suspended solids, which you now know what that means, out. So that happens quite a bit as well. Next problem, dumping. So dumping implies, as it says on the screen, that you're being irresponsible. It's not really being irresponsible. We've got too much flow and we don't know what to do with it, and we've got an old pipe network and it's raining a lot. It's a stressed system. Illegal. So it is actually a legal thing to do. We're permitted by the Environment Agency to do this. And again, with that whole wording of the extreme weather events, I feel like regulations have to be really a bit more strict on that and defining that. But it's hard with, us not knowing what the future of climate change is going to be for us. That's a bit of a challenge in itself. And it also implies that there's a choice to do the wrong thing here. And I said earlier about it's not one individual's responsibility, choice to be doing this, but also as a water company, you don't want to be doing this. It's something that is happening, yes, but it's not something that you would ever choose to do. Normally people in the water sector, like you so kindly put in my introduction, I'm a big diver, I love water. I bought my own tap water. I trust the tap water, by the way, I'm drinking it. I dive, I swim, I love water, I love the rain. I shouldn't be in the East Anglia, which is the driest region in the UK. I should be back in Wales and South Wales, where it rains regularly. So nobody wants to do this now. And if you work in water, I don't think you're doing it for the salary, you're doing it because you're interested in water. Unless you're one of the CEOs on a lot of money, then maybe you're doing it for money. So where are they? Everywhere is the answer. Absolutely everywhere. And I think that's why the media have started such a field day on this, because they're always looking for the next sort of secret expose. And this is a really good potential. But just looking at that map, you can see there's a lot of this going on. But basically anywhere where there's like a river where we could be offloading some of this waste, some of this water, there's essentially a storm overflow. This is just it for Cambridge as well, so I just thought it might be of interest. And I've included a link there at the bottom left. So if you wanted to just go on the Rivers Trust website, maybe if you've got a dual screen, you could do it while listening to me. And you can find your house if you want to. It's very well detailed. But the one advantage of this map, I think, is it shows that we are aware of the extent of this issue. We're aware that the public is interested in this because this is freely available data that anyone can access. And we're trying to share with people that things like this exist, because we don't want you to just read the headline of a newspaper and be like, "God, this water company dumping all of this illegal waste." Actually, we're trying to keep on track of it and we're trying to monitor it. But the one thing we don't know is the real impact they have on water quality. As we know, microorganisms live in sewage. It's a really great environment for them. They're the things that are digesting the sewage for us. And we just don't know what the impacts of that are in terms of water quality. And this could be the impact on things like fish within those rivers, or this could be the impact of this on people who might be wanting to swim in those rivers. We've not got very good bathing water quality standards in this country. So we're not entirely sure of the impact of this at the moment. We know where they are, and we're quite good at the quantity of water they're discharging. I'm sure if you've read any of these newspapers, it would tell you how many thousands of litres are being discharged from these points into your local river. But the one thing we don't know is the impact of the water quality. So how can this be stopped? So we actually stopped building these new combined sewer overflows in the 1960s. But like I said, we've got so many of them in place, and it's so difficult to dig up the grounds that even though we stopped building them and we can't build them anymore, we still have so many of them, as you saw from the map. It's very difficult to get over and replace them and so on. Another thing that could be done is just trying to hold more water for longer periods of time, as an easy way of saying it. But again, where are we going to fit all of these massive tanks of water? What land are we going to use for this? Where is that land coming from? And it's literally just a way of delaying this. We're just trying to store rainwater in tubs to stop it overflowing into the river. It's not a very good, a very effective way of stopping this. And the final thing we could do is to treat the storm overflow discharge itself. So nature-based solutions is like having gardens of wetlands almost, especially in urban areas, which then capture and slow down the rainfall rate. I was speaking to some researchers last week at a university about this, and they had like an architect draw some pictures of what this could look like, and it looked beautiful. But the question I had for them is land use. Where is this land coming from? What houses are we going to be demolishing to fit all of these? They looked beautiful. Like the artist did an amazing job, but I'm just not sure on the future city how that could even be feasible for us. But I think it's the way forward, and these researchers definitely say it's the way forward, but I don't know how yet. One of the biggest barriers for us in fixing this problem is money. Customer bills, sort of, they can fluctuate quite a lot, and the capital expenditure just for a water company existing and maintaining the quality and the quantity of water today is increasing. Things like climate change are really going to impact the source water quality that we have today. So for instance, rivers there'll be less water in the rivers, and because there's less water in the river, it's mixed in a lot more with the silt, with the stuff at the bottom of the river that you don't want in your water. So they're going to require more treatment to get it to the same quality that it's currently at. How can water companies stop this? So this is just from Wessex Water, and it's literally just a quote of what they specifically as a company are doing. And many of these water companies, they do have these statements out there of what they are doing about these overflows. But I'm not necessarily convinced by this, if I'm being honest. Is it enough? I'm not certain. I think since the privatisation of the water companies, they operate as very separate entities. And I think something has to come from like a top-down approach. I think we have to unite the companies together. I'm not certain it's enough for one water company to state something like these increased environmental and public health monitoring. That's not a smart goal. What does increased I mean, if you're not currently doing any monitoring, just monitoring one river or one area of a river, is that enough? I feel like something has got to be done together, and we need to work out where the money is coming from to do that. What can you do? So don't put things down the sewer. I think really does help Fats, oil and grease is a really big one. I was in my house once and I saw my friend, he'd just been cooking some bacon, just pouring the bacon down the sink. I was like, do you not know me? How many years have we been friends? You can't do this. It goes in the bin. It goes in the bin. So there's different techniques there that I think, just to remind everyone really, that it's not just a water company issue. It's also, if you've ever put something that shouldn't be down the toilet, Cambridge Wastewater Treatment Works, there's a story that the operators like to tell, but someone flushed their dentures down the toilet. But the most surprising bit was the person went to the wastewater treatment works and asked for their dentures back. That's a surprising bit. I mean, I guess they're, you know, at least they're not permanently putting things into the sewer network if they're collecting it back again. But just yesterday, when I was at the university at the conference, there was someone who had been putting down the toilet the hand towels, the toilet roll that's not toilet roll, down at a wastewater network conference. Almost ironic in the audacity of that, you think. And so there's also stuff the public can be doing. Can I check how we're doing for time?
You want another quarter of an hour, 10 to 15 minutes.
Okay, thank you. I didn't
Thank you, Natalie. Perfect timing, Natalie, if that makes sense.
So I've spoken about what the sector as a whole can do to try and work towards solving this. I've spoken about what some water companies are doing to try and solve this. So how am I trying to stop this? What am I trying to do? So I'm trying to use different technologies. My vision, I guess, for the future is a bit like how speed cameras are able to monitor roads. Have a similar system, but for rivers. So almost like a thumbs up, thumbs down, a traffic light system. Can I go in the water today? Can I get my kayak? Can I go diving in this water body today? Yes or no? And the reason why I use the speed camera analogy is I've spoken about this before, and the answer I got back was that's ridiculous. How we monitor that? Could you imagine the monitoring that would be required to put this in place? But then when I said, well, we do it with roads, we monitor the speed of certain cars on the roads, I think it really helped to put things in perspective to some of the people I was speaking to this about. If we can do it for roads, and I think we've done it for roads because it's a priority for us, I think we could do it for rivers as well, even if it's just some of the main rivers that we've got here in the country. So this is what I'm personally, some of the research that I'm doing, some of the work that I'm doing at the moment is looking at doing. So in a nice circle fashion, can anyone guess what this is? I've got the chat open, and we've also already got some questions coming in, but can anyone in the chat maybe write a message if you're feeling brave about what you think this might be? And if anyone in the room has an idea, feel free to put your hand up and I'll repeat to the chat, to Zoom, what it might be. Okay, I'm not seeing anyone yet. Maybe no one's feeling brave. Maybe everyone's gone to sleep. Maybe I've been talking far too much. I don't know if everyone can see that reply there. No. So I'll give you a clue. Oh, I'm not sure what's changed. Yep. So this thing is found in all sorts of different environments. So we've got there someone's mouth. We've got a river water environment. We've got tap water. It's also found in tap water. We've got a pristine looking wastewater treatment works. They don't look like that in our country, but it was much prettier than the alternative. So this thing is actually, you brush your teeth at night, yes, and you don't have any secret midnight snacks at night, and yet you still have to brush your teeth again in the morning, and your teeth are really gross. Maybe you've got some smelly, but I have smelly breath. I'm happy to admit it. Maybe they're a bit sticky, a bit gross. So I'm just reading the chat. It's not toothpaste, but we did get someone who got really close, but I just didn't say it to you, just because I didn't want to spoil it for everyone. It is actually a biofilm. So the reason why you have to brush your teeth in the morning is because biofilm has grown on your teeth overnight. So microorganisms produce biofilm when they reproduce. And I like to think of it as like a sticky spider's web. It's a sticky material, and it contains all the building blocks required for life. So it sticks to everything. So I don't know if you've ever put, so in the water sector, this is quite a common analogy, but I'm not sure how well it translates. If you put something in water or wastewater, so normally I say like a probe, and you leave it there for a week or 2 weeks, and it gets really gross and really sticky, it's quite often a biofilm that has grown on that thing. So I don't know if anyone's got a pond and has put something in the pond and then it's got really gross. I mean, it could be algae, to be fair, but it's normally a biofilm that's grown up. So we have biofilm on the inside of drinking water pipes as well as in wastewater pipes. It is completely normal. Again, it's the microorganisms that exist all around us, but some people might be put off their tap water. I will say it again, I have said it once, but I do drink tap water and I'm continuing to drink tap water despite knowing this. So that's what biofilm is. So this is the probe, and I'm just going to give it to the room. Sorry, people online. Just have a look at it if you want. So this is, I work with 7 different technologies at the moment that I project manage sort of around the UK, both in different water companies, and I'm also starting to do some work in different companies as well. So for instance, companies who manufacture paper like Essity, you might have heard of them, they're quite a big one in the UK, but paper manufacturers, to manufacture paper, it takes a lot of water. So because they use so much water, it's actually cheaper for them to treat their own wastewater. So as well as a factory producing paper on site, they'll also have a sewage treatment works on site. So a bit like earlier when I mentioned that local brewery that I visited recently, and it was they were starting to get to the point of their company where it was cheaper for them to treat their own wastewater instead of tankering it all away. Because when you tanker waste sewage, as you can imagine, it's a lot of volume that you're transporting. Whereas if you use different techniques to get rid of some of the water from the sewage, then you've got much less volume of stuff to be transported via vehicle. And fuel prices are ever increasing. So just for that one brewery, like I said, it was £50,000 a year for them to tanker away their waste. Whereas if they had their own wastewater treatment facility on site, it would be free for them because they'd be treating their own water to a standard that could then be discharged into a river. So this particular sensor is designed for this biofilm to actually grow on it. So normally microorganisms, when they produce electrons as part of that reproduction process, and those electrons are sort of lost to the environment. This particular sensor, it acts like a microbial fuel cell. What it's doing is it's capturing those electrons that are normally lost and getting a quantification of those electrons. So what that means is that we're able to detect the microbial activity of any water body. So the reason why I'm interested in this technology is because it's real time. So we can take one reading every minute to be looking at what is happening along those various points of that specific river, and then updating like the map of the CEOs, but almost like color coded, like green, yellow, red, depending on the levels of microbial activity within that specific water body. So that's sort of where I can see the future of CSOs going, because like I said, one of the big problems that we've got is really trying to understand the quality and the quality implications. And then the news at the moment, yes, we can disprove that it's raw sewage. We can say, I think dumping is a harsh word. We can say all of these things, but when they say it's impacting people's ability to bathe in the water, it's impacting the sea, we can't yet for certain empirically with data say, no, it's not. And maybe if the answer is yes, it is, then we could do some kind of appeal, get some more money fed into the sector to then get some research and do something about this, sort of justifying it as a challenge. I think previously, because it's something that's existed for so long, it's been quite difficult to drum up support for this. But I think lockdown has really helped us a lot as well, because people now, or they did over lockdown, started to really care about their local environment a lot more. Started to go for walks for the first time ever in their life, maybe go to the local country parks that they've not visited since they were children, just because they couldn't do the sorts of things that they would normally do. So I think that's really helped our case, and people started using local water bodies a lot more. So that's sort of wastewater, some work that we're doing within it, particularly in relation to combined sewer overflows and water quality. How much time have we got?
5 minutes now.
5 minutes. Oh, what shall I do? Shall I go into drinking water or not? Yes. So very quick, you'll have to stop me at the 5 minutes or give me some sort of warning or something, because I get excited and I go on a tangent. So on the drinking water side of things, we use a lot of chemicals, but they can have unintended consequences. So one of the big ones is the chemicals can be seen as being wasted. Some studies suggest that less than 1% of the tap water that is produced is consumed by humans. We are washing cars in it, we are gardening with it. The water that is in your toilet, don't say Natalie Lamb told you to do this, but if you moved into a new house and you had a new toilet, you could drink the water from your toilet, because it's the exact same quality as the water in your tap, as the water in your washing machine, as every other water point in your house. Your garden tap is the exact same as the tap. That's something called grey water reuse, and it's something that we're maybe looking into in future, is sort of having a separate water system within your home for water that's already been used once, to then repurpose that water again. But it's not something that we currently do here at the moment. But yes, we're dosing chemicals which are then being put down the drain. And then on the wastewater side of things, we have chemicals that we've got to get rid of from the tap water before it can be discharged into the environment. So we're paying to put them in, we're paying to take them out. The water sector is normally you're an expert in water or you're an expert in sewage. You don't normally find many people who sort of go across the two areas. They're normally quite separate. It's quite a big flaw for us, I think, as an industry. Even wear different coloured clothing depending on whether you're water or waste. There's a big rivalry there about if you're blue or green. So especially with them being expensive, then it's not very good to waste them. So we use chemicals both within water treatment itself and within water distribution. So a big focus on this talk today has been on the pipe networks that we have. So we do treat water sort of twice. So we dose chemicals just before the water goes into the pipe network, because on average in the UK, the time it takes between the water being produced at a water treatment works and the water arriving at your tap, it's actually, I normally get you to guess this, but reasons for time I will not. On average, it's 3 days for the water to leave the treatment works and get to your tap, which is a long time. There are some places in the UK that are as long as 6 or 7 days. So we don't just treat the water itself, we then have to try our best to maintain it through these pipes that I said earlier that could be 100 years old, maybe more, maybe they're corroding. If they were put in place before the 1960s, they could be made of lead, which is toxic for humans. But we dose chemicals to stop that being a problem. But yes, we use a lot of chemicals to treat and distribute the drinking water. One of the chemicals that we dose sort of those 2 times is chlorine. Chlorine can cause problems with people. It can be quite dangerous as a gas, not for people drinking the water. The biggest concern is the people on site. I know of a site that they kept a lot of chlorine. You can have 30 days worth of chlorine gas as legally allowed to be stored on one site at one time. And the local town next to that treatment works had a siren system. So if chlorine gas had been accidentally released, that everyone in town would have to try and evacuate with the sirens, which is fine. But the people in the water company who were based on that site, if the sirens went off, they had to go to a special locked room where they would put on a hazmat suit, and it would extend, the purpose of it was to extend their life. It wasn't to help them survive. So extend their life long enough to contact family members and say goodbyes. So they're not, you can't run out on a gas. So it can be harmful, and it's something we're trying to move away from really in this country. You can also have things like that you see in the news sometimes, that people are allergic to their tap water. They're normally not allergic to water. They're allergic to the chlorine that's in their tap water. So it can cause people to have rashes and so on as well. But that's not as exciting as hazmat suits and alerts and alarms and things. Phosphate is the one that's of interest to me, particularly with my background in microbiology. Phosphate is one of the building blocks for life. And is really important to microorganisms. You might have heard of eutrophication, which is sort of the uncontrolled microbial growth in water bodies due to nutrients such as phosphate. So phosphate is dosed orthophosphoric acid, to be precise, to form a protective layer around the inside of pipes to stop the lead that I mentioned briefly earlier from leaching and entering the tap. Again, the lead has been banned since the 1960s, but it's still in place because of the issues that we said about earlier with the pipe replacement. In particular, lead is normally found within the home as well. So if your house is from the 1960s or earlier, it probably has some lead in it. Phosphate is really expensive. It's a mined resource. We get a lot of our resources of phosphate from places like Morocco. A lot of it is in the Middle East. There was an earthquake in China 6 years ago now, which stopped phosphate mining for a few days, and the price of phosphate for water companies tripled overnight. And there was nothing they could do but pay the costs, and bills didn't increase. And phosphate is really important on the wastewater side to get rid of it before it's being discharged into rivers and so on. So it's very expensive to dose it, and it's very expensive to remove it. Fluoride is a nutrient. It is not, this one is not about treatment, but I just thought it was interesting, and there's lots of conspiracy theorists out there who are excited about fluoride. And so fluoride was some of the first recorded uses of it, like proper uses, were in concentration camps to experiments to see the impact of it regarding docility of humans and if it made an impact. And because of this, it's got quite a negative view, and people believe it has been dosed at times to try and make the population docile, but actually it's been dosed to help protect people's teeth against tooth decay. And I'm personally against it, just because it's not very efficient, because so much of the water isn't being drank and it's being put down the drain. And they do lots of better ways of doing it in other countries. In Russia, they put it in the milk, because I mean, who's washing their car or showering in milk? I mean, maybe there's a few people out there, but I imagine it's not the majority. In Germany, they have like tablets that school children have, because it's most important for the school children when their teeth are developing. In Canada, they have fluoride day in some areas in school, where the kids are given like a little mouthwash on a Friday and rinse and spit at lunchtime at school. I just think there's better ways of doing it. And now I'm going to skip ahead because I know that we're short for time. So my PhD work that I was doing, I sort of designed and manufactured some fake pipe networks. I don't think that's going to work. Designed and manufactured some fake pipe networks, that sort of next generation material. So none of this 85-year-old lead pipe flaking corroded business, but really, really good plastic, fresh pipes. And I was using the flow cytometry method that I was talking to you earlier about, using lasers to count individual numbers of cells to see if we could get rid of these chemicals in the perfect network and still have the same great quality water that we have on the tap. And I found that, yes, it was successful. So I think potentially in future we could do some more work and maybe get rid of some of these chemicals in the drinking water. But as long as we have this excellent pipe network, we solve some of those challenges that we've been speaking about today, and our sampling is not done by sampler choice, and is done more frequently and isn't reliant on one sample here, one sample there, because it's just not a good way of properly quantifying the quality of water of any sort, whether that's water or wastewater. I had removable sections of pipes, so I was looking at the microorganisms both free flowing within the pipes and also growing on the outside of the pipes. in the form of a biofilm. So my presentation today, yes, I have spoken about combined sewer overflows. I've spoken to you about water, importantly about microorganisms. So I hope you've had a bit of a whistle-stop tour about some of the exciting things that are happening in water, but also some of the challenges that we're facing as well, and how it's really difficult for us as a sector to take on these challenges alone. We need the public to be behind us and not against us. And we also need some extra help from, I don't know, other fields, other industries, to help bring us to the current century and think of some more innovative techniques. That's really going to help us with this. So I hope you've enjoyed the presentation. I'm sure you've got lots of questions, or at least I hope you've got one question. But yes, thanks very much for listening to this.
Well, I have to say, Natalie, I thought that was a wonderful lecture. Thank you very much. I've learned a heck of a lot, and I'm sure we all have. And I would like to thank you, because you've borne in mind we have a very varied audience with very different academic backgrounds, and you led us all into it, which I think is really good. A bit of a model, I think, for some others to follow, where we can pitch in too deep at the beginning. So thank you so much for that, Natalie. Now, I'm going to start off with one question, and then I'm sure there'll be questions coming, as I've seen them coming on the site there from Nicholas. But I wanted to ask you, it seemed to be listening to you. There's a big problem because we as the public are too passive where water is concerned. Of course, we react when there's a newspaper report about sewage being, but actually we are doing a lot of wrong things, as you rightly say, and I've suffered from our neighbours dumping the wrong things in their pipes. I've actually suffered personally from that, our neighbours doing the wrong things. And it seems to me that we need a very big education programme with the public on what you've been saying to us effectively. We need to understand water more. Would you agree with that, Natalie?
100%. So that's why I'm part of the STEM Ambassador scheme. So during my PhD, I went to different schools. So I went to a different school every term, and I delivered a series of 7 lessons a term per school, just on some of the challenges that we face in water, because I think it's really important to start the conversations when they're younger as well. And what I was actually finding with some of my pupils, they were going back to their families and they were saying, should we be doing this? Should we be doing that? And I think the more you emphasize that waters actually can be quite, just things like the hazmat suits and stuff like that, I think it's really good to capturing their imaginations and getting them to speak about that. And they go in their homes and they're like, what is this pipe material? Is it copper? Is it lead? What is this? I think just that little bit of awareness. And I think going to the children is much easier. I've also done some campaigns with adults as well. But the biggest question I get really from the adults is, it's normally just complaints about the bills and the prices. Yeah. But what I say in response to this is, imagine that tap in your house was actually red wine. How much would you pay to have red wine on tap? High quality red wine that is being monitored. You could leave your tap on in your home all day long if you wanted, all day. I mean, yes, if you're on a meter, you'll have to pay a lot of money probably, but you could leave it on all day, every day. And many people have leaks within their houses, so they are kind of doing that. What other sector? Imagine there was a bottle in your house and every time you pressed it, you got a McDonald's burger. It just instantly appeared. So yes, I definitely think there's a piece there around that, and also around responsibility, because people who are homeowners actually own the pipes within their house from the boundary box, which is the pavement in front of the house, and then inside of their house. So say, for instance, if everyone replaced all of their lead within their homes, maybe we wouldn't have to dose phosphate and pay for phosphate to be put in place. But the reason why we're doing it is because lead is sampled for at the customer tap. So we would require everyone to update and upgrade and maintain their own pipes, but the water sector have to get the trust that they need to then stop dosing some of the chemicals that they dose at the moment. So yes, I think it's very, very
Thank you very much. That's, yes, very, very helpful. Nicholas, may I turn to you now to come in with the questions from the Zoomers, please?
Yes, the first one was, you referred to ATP, and we were asked what it was. The answer has come back as adenosine triphosphate, which I remember from biology being involved in photosynthesis.
Yep.
Is it the same stuff?
Yes, yes, it is. Yeah.
Just right. Should all houses use grey water? You touched on this.
Yeah, so I think it's a very good system to use. I think we should be using it in this country. I mean, the biggest challenge for us is, again, it's such a shame, it's infrastructure. So just having the dual pipe network layout, I think if that was introduced at all new properties being built, all new builds, and there are certain properties that do have that built in, but they're very expensive eco homes pitched at a very certain demographic of people who can afford to live in an eco home, or with like built-in solar panels and so on. But I think if all new homes that were developed had that system, I think that's a way to start introducing it into the public view. It can be so wasteful, but equally at the same time, even if you've not got a grey water reuse system in your homes, you could still do things, and many people do, like capture their bath water to then water their plants with it. But for many other people, that's not something they would ever, it wouldn't even cross their mind to do that. Like, why would they do that when they can just turn on the tap and get more water? So yes, I think it's a good system, but it's challenging.
I live in a house where all the rainwater goes into water butts, and then if they overflow, it goes into soakaways. Surely we should be doing far more in that way.
Yes, definitely. Rainwater harvesting is definitely sort of front of mind, especially when it comes to sewer overflows. And I think rainwater harvesting, not just on I think we're given quite often a responsibility to the individual to do rainwater harvesting on a domestic level, but actually I think many offices, many companies, I don't really see many businesses who do rainwater harvesting. And if you think of the footprint of those buildings compared to the footprint of your own home, I think you could get a lot more water from that if a company was to introduce that. We have a question from the room, if that's okay.
Yes, please.
Yes, I don't understand why the water companies are not working alongside the councils and the planning to actually force the use of the rainwater harvesting in all new builds. And then particularly around here, we've been building and building for years and years. We're very short of water, and as you say, we're wasting such a lot.
Could you repeat that so that the Zoomers hear it? Thank you very much. If you could, Natalie. Yes, thank
no
you.
problem. We had a question surrounding why the council's sort of not working with the water companies to be implementing some of these solutions, such as rainwater harvesting. Did I miss anything out, do you think?
No, that's fine. Yeah.
And I think they should be, is the answer. I think housing standards is not something that I know that much. I've moaned about it a lot in my thesis, and it was cut out for not having academic rigor and just being a rant. I'm quite good at that. But yes, I think, you know, housing standards, they are quite stringent and quite tight, and everyone's trying to do things for the lowest possible amount of money that can be done to make the largest profit. But I definitely think it should be implemented. And there's a problem as well in sort of housing regulations regarding the piping and the dimensions of things. Again, just trying to cut corners to go as close to the regulations as possible, even at the detriment to the water companies. There's definitely some tension there, I think, that could be worked on.
I know I had a water tank put in when we did renovations. So I'm sure we could come up with a scheme that people are renovating, all of these things are put to them, like the water companies, you know, liaising with the people and the councils. And I think you would get a lot of people who would be for that, because it is an expensive thing to do.
This is about renovation, isn't it, Natalie?
Yes.
But yeah, for the Zoomers.
So regarding renovations and sort of implementing some of these new techniques when you're renovating your house, I think it's just a big matter of the public not necessarily knowing. So just on the lead pipe issue, just as an example, Northern Ireland Water, obviously in Northern Ireland, they did a scheme a few years ago where they offered to pay for the lead in customers' houses to be replaced for free if they were below a certain household income, completely for free. They would go in and replace all of the lead, and their uptake levels were below 10% for this scheme. And the reason being is people didn't want their gardens dug up.
No.
They either didn't care enough, they didn't respond to the emails that they were receiving, or they didn't want their garden dug up. And I think it's because they don't realize the challenges regarding this. I think if you are aware of these challenges and you do have the money, I think there are steps that can be taken to implement some, you know, some techniques to do something about this. But I think if you don't have the money or you're not aware, it's a really difficult thing to do, and it's really frustrating, because if you're an individual in that situation, you're trying to do your best to help the environment. It's not necessarily about, I don't know, if that's something like solar energy, there's an advantage there because you're saving money on your power. There's a clear advantage. It's not necessarily got to be an environmental driver, but unless you've got a smart water meter, and even then I find that water is very cheap compared to some other things that we use. So maybe not a popular opinion, but maybe our prices have to increase. Maybe that's the answer. I'm not certain.
But you're right, that main pipe from the outside meter right to the stopcock is the one that's nearly always lead in the older houses. And that's always through the garden, isn't it?
Yeah.
And that's why there is a resistance to it, because the garden has to be dug up to replace that lead piping.
Yeah. And there's even many people out there who don't realise that pipe is their own responsibility also. I don't know, I bought a house in January, and all of the documentation, it was like, where's the stop tap located?
Yeah.
What's this? What's that? Who owns the sewer network? Who owns the drinking water network? Don't know. So
Yes, it's interesting.
People just
Nicholas,
don't
can
know.
I come back to you now? I'm sure you have more.
Will one be destroying lots of useful microorganisms by drinking boiled water?
So the thing is, if you boil your tap water before consuming it, you will, it's almost like always using disinfectants at all times, always bleaching everything at all times. So the answer is actually yes, because you're not exposing yourself to those organisms. You could give it a go and experiment if you're up for that. It's not something that I've done. But for instance, I don't know if you've done this, but when you go on holiday to another country, and the people there, the local people are drinking their tap water fine, and then you have a Coke with some ice in, and you get horrifically ill from your ice. And it's because they've built up a tolerance to their own tap water. That's why they're not getting sick, and that's why you are. It's just a different microbiota. It's just a different community of microorganisms within that tap water. So if you want to boil your water forever, then that is not a problem whatsoever. But if you want to switch between the two and maybe want to boil some tap water sometimes and then have some tap water, maybe you'll just go through a phase of 3 years and then want to just drink tap water again when you see the energy prices, then that might be a problem. But you say about that, but people use Brita filters, and Brita filters is essentially filtering out some things which could include microorganisms, because they're actually a carbon-based filter, which is something that we use on site as well. But quite interestingly, people don't often follow the recommendations for replacing the filters within the Brita filter. And in that situation, you're improving your gut microbiota, because you're actually filtering all of your tap water through a nice layer of microorganisms. So we've got some advice there for if you want to increase the microorganism concentration with tap water or decrease it.
Very interesting. Nicholas, any more?
Did you ever experience vast disturbing amounts of mercury in our drinking water? If
No.
yes, where?
No, I've not seen high levels of mercury. So when I worked for Angling Water for a year as in their operational scientist team, my focus was mostly on pesticides. So I'd get like a big spreadsheet for the whole region, and I would go through this spreadsheet and work out if we needed to stop abstraction, so stop taking up water from the rivers, if we could cope with it, if there was any nasties in that river water that particular treatment works on that day couldn't handle. And I didn't see anything. I know that there's a lot of stories in a lot of different countries with problems with mercury, as well as all sorts of things. They've got a lot of challenges elsewhere, but for us, it's not really at the forefront of our minds, because it's not really that much of a challenge for us.
Is there anybody in the room now who'd like to ask another question? Please, yes, thank you.
In a way, it's, I always worry every time I use a Harpic bleach down the loo.
Yeah.
I'm imagining all the cleaning materials used in every household. And how difficult is that to make drinking water?
Yes, that's about the chemicals put down the loo, Harpic, for example, in other words, bleaches, etc. Yes, thank you.
I'm just quickly putting my laptop on charge because it is about to die.
Oh, yes.
And I wouldn't want to lose everyone on Zoom just as they're asking lots of interesting questions.
Oh, no, that's important. Well spotted, Natalie. Yeah.
Just 1 second, sorry.
Behind you.
Thank you.
Yeah. Over here. Yeah, all right. You can do it.
So chemicals down the toilet, that's not necessarily a concern on sort of a household level. You will impact the community's sort of the biofilm that's growing on that sewer network pipe. But on a household level, that's not of concern. However, it is of concern with big companies that are mass producing things. So they can really kill off the microorganisms going into a sewage treatment works. And some of the work that I'm doing with some of the sensing technology is about trying to alert the wastewater treatment works when they're going to have a massive killing off effect. Because if you suddenly have a lot of microorganisms dying, they're not going to be able to digest the sewage. And then you're going to have almost like colonies of microorganisms forming that you don't want to form, that aren't very good at digesting sewage and are instead causing blockages like everywhere in the works. So on an industrial level, that's of concern because they're also putting some really hazardous chemicals down the drain. But interestingly, the opposite can also be true. So in the UK, we have a lot of companies that manufacture sugary drinks like Lucozade or Ribena, or manufacture fruit juice. So we have quite a lot of those facilities left, and they put down a lot of sugar into the sewage systems. And sugar is a great source of food for the microorganisms. So you have a massive increase in growth. So sort of the opposite of that happening. And then suddenly, if you think of it like the food web situation, so you've got loads and loads of food. So the microorganisms eat all of that food, but there's not enough oxygen provided to them to maintain the activity levels that they're doing. And then the populations die. So lots of food can also be a problem. Interestingly, over lockdown, lots of pubs put loads of beer down the drains. It was very sad loss to the country. So yes, beer, like we've just said in the room, is an excellent food source for microorganisms. So lots of dairies as well were putting milk down the drain, similar situation. So in the pipe network, there was massive growth on a scale we've never seen before. And equally at sewage treatment works, they were suddenly toppled over by food sources on an unprecedented level. Normally they can cope with the sort of chemicals because they the treatment works operators, they're really, really good. They really know their sites. They're incredibly knowledgeable people, and they've been there normally for years and years and years, and they really understand it, how it works. And you speak to them and they say, oh yeah, that company, they discharged that orange juice on a Wednesday at 3 o'clock. So we know to watch out. We've got to put the blowers on a Wednesday at 3 o'clock ready for the fruit juice. But the things like the brewers and the dairies, we didn't know it was happening. It knocked a lot of sewage treatment works off their feet because they weren't expecting the levels of activity that they got. So a very rambling answer there, and I just thought it was of interest.
Very much so. Nicholas, any more from you?
Yeah, a lot, yes. In out of the way places like Peru, they have separate containers in the toilet for the loo paper. Is that advisable? Separate that.
So in this country, in the current setup, you can put toilet roll down the toilet. That is no problem at all, as long as it is normal tissue paper, biodegradable tissue paper. The issue that we have is wet ones that say that they're biodegradable on them, and what that means is that they degrade in if you put them in landfill, then they will
Yes.
degrade over time. It doesn't mean that if you put them down the toilet, they will degrade. But tissue paper for this in this country is no problem. In some other countries, their pipe network isn't as resilient. Can you believe I'm saying it's resilient after this talk? Isn't as resilient as ours, so it can struggle to go down. And our first treatment step on the wastewater side of things is massive screens and rakes, where they take away all of the toilet paper and things like grit. So we obviously have drains in the roads, and it rains on the roads, and then a lot of grit goes down. We then can we're starting to recycle some of that stuff, so that grit will then go back out to the roads, and then when roads are repaired, they can use recycled grit. And similarly with the tissue paper that's being gathered, that can then be used again potentially, depending. So that there's no need to do that in this country. But I did see a toilet at Cranfield University recently that was just a one-off at the moment, but maybe will be used in future, which separates liquid and solid waste on the toilet using it. It's like a big sponge that you sit on. But I thought that was interesting, and the concept of the liquid waste going somewhere different from the solid waste is quite a new one for me anyway.
I can see we're flush with new ideas. Go on, Nicholas.
Do you random go into shops and test bottled water? And why does bottled water taste different?
Yeah, because it doesn't have chlorine in it mostly. So normally when you go to a different place in the UK and you taste the water and you're like, this is a bit odd. Normally it's because the chlorine concentrations differ between the different places in the UK. I mean, it could be because the source water is different as well. It's difficult for me to answer this one because I'm so firmly, my whole career and all of my research and my qualifications are all in tap water. So hands up, I'm very biased in the tap water versus bottled water debate. It's very difficult for me to remain neutral. But I can tell you, if you're happy to have some biased knowledge, that the regulations, the standards for bottled and tap water are really different. So in bottled water, it gets sampled before it goes to the shops, and they don't sample it in the shops. So whereas the water arriving at your home is being randomly sampled within your area at your point of consumption, the bottled water isn't being sampled at its point of consumption. So it's being produced, it's getting sampled there, but then when it's on the shelf, it's not getting sampled again. The regulations, so it's not sampled as frequently, it's not sampled for as many parameters, depending on what the name, if it's mineral water, there's different amounts of treatment allowed. So for instance, some of them, they're not allowed to dose chemicals, so sometimes the treatment isn't as extensive as we would use, but again, that's me being very, very biased on the matter. So apologies for that in advance, after the fact rather.
Nicholas?
So certainly if you see our family, the water bottles are filled from the tap. How do you clear the blue dye from blue block cleaner?
So I don't know the answer to that one, but I can tell you an interesting story that we get quite a lot in the water. So we work on, there's all water companies have like a team of people who work on the phones and get customer calls. And one of the most popular customer complaints that water companies will get will be, my tap water's coming out bright blue, like fluorescent blue. And what you always ask them is, have you just put a toilet duct in your toilet? And the answer is yes. And you're like, well, you must have at some point used a plumber who have connected your toilet to your tap water, and you are drinking your toilet water. And that is why your tap water's coming out blue.
Oh dear. You can see you're bogged down with that one.
Right, we've got people saying thank you, but can UV sterilisation not replace some of the chemicals to clean the water?
Yeah, so most works in the UK actually use UV. The problem being, so, you know, I spoke about water treatment sort of happening in two stages. You've got the treatment of the water itself, and then you've got that extra bit of treatment to protect it as it goes in the pipe system. UV can easily be used in the treatment method, and quite often is. The only disadvantage really to UV is the clarity, the turbidity of the water's got to be really clear. So you've got to be able to see through the water. Otherwise, the UV light can't penetrate through the water to then deactivate the cells that it's aiming to deactivate. But UV is used a lot, and it's also can be used on the wastewater side of things as well, if there are particular consents that have to be met before it discharges to river. But the problem with it is, how would you then protect that water on its journey through the pipes? If there's a hole in a pipe in the centre of Cambridge, there's a burst, and the water quality is impacted, there's then nothing protecting. I think chlorine, it gives people that. One of the barriers to my research that I had from people actually was, if the water gets contaminated, at least chlorine's there, so at least there's some protection in the pipes. But my response to that, and I'm just sort of having my own argument with myself just now, apologies for saying tufo. I went to Mexico with my research in my first year of my PhD, and some of the people there had their own point of use UV filters. So at the tap they had UV, they paid for their own UV system. And that would be the perfect answer to that at-home UV treatment. But that again leads us back to this question of, are people aware enough? Would people do that? Could we trust people? Would they change the UV cut? Would they change the bulbs in their UV machine? Or would it just be like an extra source of microorganism contamination? So yeah, UV is an interesting one, but we've got a big pipe problem, I think.
Yes. Well, I think that we ought to be now. Pity coming to a close, but that's a very good thing to end on, because it putting responsibility on us as well. I think making the choices, making the differences, because it seems to me we do so many things. But that's been an absolutely splendid lecture. I think everybody would agree with that today. Very much. I think we should give you a very big hand. Not just for the lecture, but for your answer to the question. I'm so enthusiastic. You would agree, Nicholas, I'm sure.
Yes, I got one great vote of thanks. Glad to hear you wanting to emphasise knowledge and an understanding about water to young people, as it's in the UN Convention on the Rights of the Child, as it's their right to clean water and to think about their responsibility to help it for others. UK has signed up to it, and people of all ages are lifelong users, whoever owns a facility. Thank you today, and wish you well in your work.
Splendid comment, Nicholas. Thank you very much indeed. And I would just make a final comment too, because I'd be very interested. Cambridge is one particular thing which isn't mentioned very much. We're surrounded by coprolite mines, phosphorus. Yes. In fact, we were one of the great coprolite mining areas until the early 20th century. It's very interesting. I'd be very interested to know the impact of the seepage from those coprolite mines. I'm not sure we know very much about it, to be quite honest. So it's an interesting thought. All these issues keep cropping up. But thank you again, Natalie, for an absolutely splendid lecture. Best of luck with your work. Yeah.
Thank you.
Really interesting.
Very good.
Very good.
Thank you. Thank you very much.
Now that will be